All right, let's get started. So let's thank Kevin and Aaron and Q for helping out with the audio visual for this presentation, because it's very much appreciated by all the people who can't be here. My name is Brian Powell. I used to work at NI a long time ago. I used to work in LabVIEW R&D, used to work with people like Greg Richardson, the star of yesterday's keynote. And then about 10 years ago, left NI, worked in healthcare for a while, worked for a local startup, working in insurance technology, where I realized that I need more of a social mission in life than selling car insurance online. So 5 years ago, I started my own consulting company. It does some LabVIEW, some kind of engineering management, organizational culture kind of consulting. That's what I've been doing for the last 5 years. Still kind of been plugged into the LabVIEW community the whole time. LabVIEW champion, certified professional instructor, not that I teach any NI courses, but I have the certification, CLA, etc. So I proposed talking about LabVIEW units, and Darren piped up with, like, don't talk about LabVIEW units, they're terrible. So Darren Nattinger, who is not here. He sends his regrets, but he yesterday got booked for the R&D expert bar at this time slot. And he pointed out the irony that he left R&D, NI R&D like 5 years ago, but they still book him for the R&D expert bar because he's still an expert. But I do have some slides that represent some of his opinions that I completely agree with. Anyway, I do have some slides that represent Darren's feedback. As I mentioned, I completely agree with Darren's feedback. LabVIEW units have some rough edges. I'm going to talk about some of those rough edges, but I still think that LabVIEW units are worth talking about. So that's the purpose of this presentation. I use them when I need to, which is fairly often. So first, our giants are female. Who doesn't know what that hashtag is about? Who does know what that hashtag is about? Okay, good. So Fabiola de la Cueva, who's another LabVIEW champion, LabVIEW consultant, and she started this thing a few years ago about our giants are female. She wrote a blog post on Medium about celebrating women, especially in technology, who are, either, years ago were trendsetters or, leaders in the engineering world, or even today. In this case, I'm going to highlight somebody who accomplished something very significant this year, but basically celebrate women in engineering, women in leadership, women in technology, and so that's where that hashtag comes from. And so the person that I want to recognize today is Brauer. She is a sailor, skipper of First Light, which is a 40-foot yacht there. She's the first US woman to sail solo around the world, unassisted, nonstop. I think the second woman ever. I think there's a woman in Australia that did it a couple of years ago. The Global Solo Challenge is the race that starts and ends in Spain. And as she began last October, finished in April of this year. It took 130 days. There were 16 competitors, about half of them finished. All but one were men. And she was also the youngest competitor. And so that's actually a picture of her sailing into Spain, into Puerto Acuna in Spain, where at dawn, at first light, she was going to finish in second place. So anyway, I just wanted to call that out. If you sailing around the world, there's a lot of engineering problems you have to solve along the way, like fixing your generators, fixing your autopilots. Her autopilot failed and that threw her across her craft and she bruised some ribs, almost broke her ribs, and ended up having to, deal with her medical situations, give herself an IV, things like that. So there's a lot of technical challenges to solve in this. So I just wanted to recognize her. Who here has actually heard of Cole Brauer before? I'm just kind of curious. Okay, I'm surprised. Yeah, just curious if it was my corner of the internet that knows who she is. Okay, what are LabVIEW units? Who here has heard of LabVIEW units before? Okay, most of you. Okay, who here has used them in an application before? Thank you to the 8 of you who raised your hand. So that's typical. You know, there's nothing unusual about those numbers at all. It's basically a way, it was a Jeff Kadosky invention. He invented probably LabVIEW 3 or 4 time frame.
Sure.
Yeah, that's probably about the right time. He owned them first, then I think Darshan Shah owned them, then I owned them, some other people owned them. That's the reason I know about them is I owned them and I owned all the bugs, got all the bug requests around them. So that's where I also know what doesn't work with units. So it's a way to associate physical units with numeric data in LabVIEW. So if you have a numeric control, any sort of floating point control, doesn't work on integers. It's for floating point numbers. You can right-click and say, show the unit label. And when you do that, a new label pops up to the right of the control where you can type in a string that represents the various physical units. Those physical units are based on the 7 SI units. Who can name any of the 7 SI units?
You said any, so I'm going to start with meter.
Meter, yes.
You could
correct.
also possibly do liter.
Liter, volume, yes, okay, good.
Second.
Time.
Oh, that's the thing you're looking for?
Yeah, those are 3. There's
volts.
7. What?
Voltage.
Voltage is not. We'll talk about that.
How about current?
About what?
Current, amps?
Current, I believe, is 1, yes.
Well, that's more than half.
There you go.
I'll let somebody else.
Yeah.
Weight.
Weight.
Resistance.
Resistance is...
Futile.
No. Oh, yeah. No, it is not.
Temperature.
It's not
Kilograms, right?
What was that?
Newtons and kilograms. Or grams.
Grams.
Grams. Yeah, somebody said weight.
That's mass.
Oh, yeah. Correct. It's mass. Mass is the actual SI unit. Yes. Here's the answer. So length, time, amount of substance, moles, electric current we talked about, temperature, degrees Kelvin, and luminous intensity, that catches a lot of people, the candela, and then mass, kilograms. We'll talk about volts coming up here shortly. Actually, the next slide. Derived units. So inches, for example, 2.54 centimeters. Hertz is 1/seconds. So you can have the inverse of an SI unit. Velocity, meters per second, miles per hour, millimeters per microsecond, which is the same as kilometers per second. Voltage, kilograms, meters squared per second cubed per amp. And then you have things like Curies. There's a decay of 1 gram of radium per second, which is 3.7 E10 hertz. So LabVIEW knows all this stuff. You can basically put CI as your unit label and type in 1 as your value there, and that is equivalent to 3.7 E10 hertz. Fortunately, LabVIEW actually has shortcuts. You can type in capital V and LabVIEW will think you mean volts. And I think I have an example here where if I do Curies divided by volts as my unit label, so CI/V is what I type into my unit label, then if you recall, volts was kilograms meters squared per second cubed per amp. So divide hertz divided by volts gives you seconds squared per meters squared per kilogram times amps. Right? LabVIEW just took care of all that just because I typed in CI/V as the unit label. And so the help window shows you what the data type of the wire is that is flowing down the wire. It is part of the data type. That's one of the important things to understand is units are part of the data type. If in LabVIEW lingo, they're called the type descriptor. So the type descriptor not only encodes that this is a double precision number, it is a double precision number that is CI/V. And so that's going to be important when we try to actually wire this to things. It's part of the data type. So I need to, if I do some math operation, it's got to be compatible with that unit. We'll get to that in a second. One of the other cool things about way LabVIEW does units is that you can also put in the SI prefixes. So gram as mass, I can put kg for kilogram. I can put H G for hectogram. Goes all the way up to yada, 10 to the 24th. Jeff K was really proud when he put in yada and yocto prefixes for these things. And so I could type in kg into the unit label and it'll treat it as kilograms. Okay, so let me show some LabVIEW stuff here. So I'll just create a new VI. Make sure this looks okay. So length, I show the unit label and say I want it to be feet. Oops, I don't know why LabVIEW did that. Right, so I've got my feet and my seconds. And that's where I could do something like a divide. And I can create an indicator. And so now my unit label on the indicator is meters per second because that's the base unit, right? So if I say 3 feet per 1 second, then that's 0.9144 meters per second. I can also represent it that way, right? I think by default, LabVIEW just kind of, does the negative exponents just because that way it's easier to stack multiple ones together and not worry about operator precedence.
Can you make the result also empirical, or does it have to be metric?
What's the question?
Make it an empirical result. So can you do feet over seconds? That's what he's asking.
Oh, could I? Yes, I could change this. Yes, I was about to show that you can change this to feet over seconds and it will change it to 3. I didn't even have to run the VI. It just, as soon as I changed the unit, it redrew the data that it already had based on the new unit. I can actually, I should probably put a delay in here. I'll do an actual loop. This is where I'm supposed to ask Nigel to put this in a loop with the...
They'll be able to do it in 15 minutes, and it's going to take you all day.
If Darren was here, he'd be yelling at you for not using Quick Drop.
I know. It's unfortunate that Darren is not here. I like to disappoint Darren. It's one of my superpowers. Okay, so now we're running this in a loop, and I could actually change this to meters on the fly while the VI is running. Right? Now, I cannot change it to an incompatible unit, so I cannot change this to degrees Celsius because that's not compatible with meters. But like I know that MI is the LabVIEW unit for miles. And so I could type in that. I could also do that on the indicators and say miles per second. And so if I wanted to say, 2 miles per second, then, okay. So that's just your simple use of units, right? Many of the operators on the numeric palette work with units. But notice I did not say all units, and that's one of the things we'll talk about that is a point Darren very validly brings up, is that not everything works with units. So I'll talk about then how do I deal with that as a way of where I use units and where I do not use units. What else do we have? So if I change this to degrees C right now, then my VI is broken. And the reason my VI is broken is that my source units are kilograms per second, and my indicator still says meters per second. So that's where I would if I really wanted degrees, I could say degrees F per second, for example, that would be a compatible unit. The VI becomes good at that point. But that's, if I were to, for example, replace this with an add, then it's not only going to not just like the output, it's not going to like the input, because I can't add seconds and Celsius degrees, right? So you have, if you're doing something like add, you've got to have compatible units. It could be feet and meters, it could be meters and meters, but it can't be candelas and meters, right? They have to be compatible units. Does that make sense? It's got to be one of those 7 SI units or the math that is compatible with that. So if it's meters per second, I can add meters per second to meters per second as velocity and come up with velocity meters per second output. That all works fine. But they have to be physically compatible. What else? We showed the runtime compatible units. Oh yeah, SI notation in units. Cool thing. Let's change this back to meters, say. Yeah. So my favorite display format is SI notation. Is there a way to make that the default?
No.
Yeah. See his pause there was, there's a hidden INI token that he's not telling me about. And so I'm going to figure that one out. Anyway, SI notation, that's where I could type in 2K, for example. Let's say 2,000 meters. And LabVIEW is actually smart enough to move that into the unit label, because the prefixes are all compatible with the unit that they refer to. So if I had, I can now say, okay, I want 0.01 kilometers, right? How many is that? That's 10 meters, right? And so that's one of the things I love about SI notation, is that, thinking in terms of K or M or U or whatever, micros and millis and kilometers and things like that is useful to me. And then I like that it just will move that into the units, because I'm often thinking about like kilometers per second or millimeters per microsecond and not having to have that in the display. Does that make sense? Okay, so use SI notation.
Is there a way to lock it so it stays to one of the unit types? Oh.
Is there a way to lock it so it stays as meters, even if we have 0.01 meters or various data?
No, in that case, what you would do is you would not use SI notation.
Okay.
At least I believe that is the correct answer. Greg R is nodding his head. Yeah, so, yeah.
I have a question. How about putting it in a strictly typed definition? That could be a way of enforcing nobody changing those units?
You're talking about the
like I don't want anybody to change it from meters to centimeters. If I put it on a strictly typed F, is there a way for people not to move it?
I don't know of one. Yeah. I'm relatively confident that there is scripting access to the unit label. So you could always, programmatically set it back if it ever changed or something, but.
As long as you're staying within the same SI base unit, changing that unit label is just considered part of the display or the value. So you can always edit the value even in a strict type def. You just can't change the data type. The data type at its core is just the numeric representation and the base unit. So as long as you stay within that base unit, you can still change it even at runtime.
Yep. It's just to emphasize that point, that being part of the type descriptor means you're compiled into the code of that block diagram. And that's what you cannot change at runtime. But just the display part of feet versus meters and all that math, that's all done at runtime.
How is this handled on the data logging side? So if you change from on the runtime one unit to another unit, how is that handled? So like in my data file, if I'm recording it in meters and somebody changes it, say meters to inches,
I get it now. So the data flowing down the wire, the number flowing down the wire is always in the SI units. So if I put feet here, so 10 meters is 32 feet. I'm doing an add, so let me change this to meters. And I probe this value. Then the value on the wire is always going to be in the SI base units. So if I typed in, 33 here, then I'm running in a loop. Okay. So we see there that, my probe is still showing 10 meters because meters is the base SI unit. If it were feet per hour, the probe would be still showing meters per second because meters and second are the base SI units, right? So then your question was, what if I'm writing that to a file? The file primitives do not natively understand units. You have to tell them how you want to write that data to a file. So then you will say, well, I want to write that to feet. So you will convert that data to feet to write it out to a file. If you wanted to just write it out as meters, it will do the right thing because that's already the base unit. But if you want, so you should care. And I'll talk in a minute about, you basically want to figure out where you want to use units in your application and only use units there and define what those boundaries are. And at those boundaries, you will need to convert to not using units. Okay. So same with reading from a file. If I'm reading from a file and it's feet, I can basically call the unit, there's a convert unit function and say, interpret this number as feet and then store it on the wire as meters as my, with units as my base SI unit. So if that's not clear, I'll show an example a little bit later. Okay. Okay, so when do I use units? I don't always use units, but I consider using units whenever I'm doing math on physical values. So for example, I want to compute velocity, meters per second, me not having to worry about that math of getting that unit math right is really a big help in LabVIEW. Or when I'm mixing imperial and metric systems. So one of the examples, let's stop this one. Yes, I wish to close the probe window. See if I can find the one I'm looking for. This is not the one I was looking for, but it'll still, I think, demonstrate the idea. Maybe, no, let's see if I can just find it. Well, it may have gotten cleaned up by Darren at some point in the past. But I had an example that I used to ship with LabVIEW that was a photography depth of field application. So like I think of distance in terms of feet, of what is in focus, like how much will be in focus. The math behind that has to do with like the sensor size, which is usually in millimeters, like 35 millimeter film is a 24 by 36 millimeter image plane. Then you have a thing called the circle of confusion, which is actually in millimeters. That is, essentially what is considered in focus or not, and that is related to the size of your sensor or your film. Then you've got the focal length of your lens, which is in millimeters. And then you've got the distance to the subject, which is in feet. And then you can compute this thing called hyperfocal distance. And there's all this math that goes into this. And if I had to also think about, feet versus meters versus millimeters, it's a real pain. But then writing that in LabVIEW, you just you do your divides and you do your adds and you do your multiplies and it all just works out, right? So that's one example that is gone in LabVIEW 2024. I had another application which let's talk about here. So I had an application that was using a counter timer board to detect when a projectile was going through some distance. And based on the timing of when it saw the projectile, then it was going to take an image at the end when the projectile was going to be at the right spot, right? The designers of this system designed all the physical geometry in terms of imperial measurement system, but the actual measurement of the projectiles and things like that was in kilometers per second or millimeters per microsecond, things like that. They were using an old traditional DAC counter timer board that had an 80 megahertz clock base, and so you had to program that in terms of ticks, which is 80 million hertz. And they wrote part of their LabVIEW application, you needed to do some math in Excel first. And so they had an Excel formula that's similar to this one that says result equals location 2 minus location 1 times 25.4 divided by velocity times 80 plus some number of initial tick values. And it wasn't documented, right? Because there was another formula that had /40 and /10. And it's what is 40? I was pretty sure that 40 was half of the 80 megahertz clock. And it was trying to get to ticks that way. And then 10 was actually 10 megahertz, as doing clock division on the 80 megahertz clock to get down to 8 times. All had to be kind of reverse engineered. I'm looking at this formula. I'm also trying to look at the code that's trying to use these numbers and then program the DAC board. And so I ended up convincing them to get rid of Excel and just use a LabVIEW VI to enter the number, and then LabVIEW will compute all this other stuff. And then my math turned into this on the lower left here, where I had sensor location. I said millimeters. My velocity was going to be in inches per microsecond. My T naught in this case was 0. So essentially to travel 2 meters, sensor location 2 minus 1. At 5 inches per microsecond, then the time to travel those 2 meters takes 15.748 microseconds, right? So I thought just being able to do that math and get the units right at the end was the big help that LabVIEW provided, right? If you're like my chemistry teacher in high school taught us about units. Hopefully yours did too. You know, you had, okay, this is going to be, you know, this value. This is going to be this value. You can't, you know, I can divide this and that's going to divide this unit out, right? So all that stuff, and this is where LabVIEW gets to handle a lot of that for you. And so that's one of the thing I like most about units is that it takes care of stuff like this for you. So cancel this. So that's this VI right there. And that's where I can, I will also put a while loop around that. Oh, I should have done while loop with button. Right, so then again, I can change this to meters and think about it in terms of, I could change this to, you know, millimeters per microsecond and say it's going to be 10 millimeters per microsecond, right? I could add in this T naught, you know, say that's going to be 4 seconds. And so then I see that it's 4.0002 seconds to travel at 10 kilometers per second. Right? Does that make sense? Anybody confused at this point? Okay, good. Okay, let's talk about problems with units. This is where Darren, I'm channeling my inner Darren. If you make one thing a unit, then everything has to be a unit, which is kind of true. You know, if I have a double with unit and multiply it by 2, then my result is going to also be that unit, that same unit. I've just scaled up my unit. And so, you know, one, it helps that if I create indicator after I've wired up my inputs to this multiply, then it will create it with the right units. So that helps. But you know, if you're converting an application from not units to have units, you're going to start chasing down all these broken wires, which is actually a useful tool, right? So when I converted this application that didn't use units to start using units and say, well, okay, this is going to be meters and this is going to be seconds and so on. This is keeping me honest about making sure I'm doing the right math. And that actually helped me understand that Excel formula because there was a place where I thought, is this 10 hertz? Is it ticks? Is it meters? What is this 10? And only once I got the diagram to where it was no longer broken, then I say, oh, now I understand what unit that 10 means, right? So this is actually a useful thing, but it does mean that you have to put units, let it flow out from where you're using it.
Am I correct that the thing that's broken here is that result does not have a unit? Because you don't want to multiply by 2 units. Otherwise, your result will be in units squared. Wouldn't it? I mean, if you multiply...
I could put a unit label on 2, and now I'm going to be coming out with meters squared.
Exactly, and which you don't want, presumably, if you want to double the unit.
You might want, but that's something you need to declare to your diagram.
Okay. So it came about because you started with regular double, you changed that to unit and had not yet changed result to unit. And when you change result to unit, it will get rid of the error.
That's right.
Okay.
Yep. Or if I changed my double with unit from meters to degrees C, but I left result as still meters, then that's another way it can break.
So it's simpler if you set result to adapt to source. There's a setting on numerics to adapt to source. So on your numeric indicators, you can do that. And then result would have automatically adapted to meters when that was wired up instead of giving you an error. And if you change the two to also be meters, then it would automatically adapt to square meters.
So if
So if you're using units, adapt to source is actually really helpful on all your indicators.
That is worth the price of admission right there. Thank you, Greg. I did not know that. So what was the second thing you were saying of when to use adaptive source? Was there a second?
Well, I was just saying that if they were both meters, it would have automatically become square meters.
Yeah.
Yeah, change that to a multiplying. Right.
Well, still work.
And so now it's meters times Kelvin.
It's an unusual unit, but maybe.
LabVIEW units don't judge. I did not know that. Thank you about that. Okay, what else? Some more things. So some features don't support units. The expression node, the formula box, various things like that. There is some magic in the format into string functions where you can actually get it to interpret your units. And if you have a complex enough format string, there's ways to, I didn't want to demo that because that's going to be complex. But you can go do that. But basically, this is my point about you need to define your boundary. So this is that's the formula function. Let me show convert unit. And if you are somebody who used the palettes, is that over here in conversion? Yeah. There's two functions here, convert unit, which says, that's where, for example, I can say, I have a number that it doesn't have a unit. It's like 3. I want you to interpret that as feet, and then the output of this convert unit function will be a length value, the SI unit is meters, that is equivalent to 3 feet, right? So that is a function you can use, like if you're reading from a file, that I want to interpret this as a particular unit, I can use convert unit to do that. And then there's cast unit bases, which you almost never use. Let me get this out of the way. Cast is still not out of the way. Where can I put this? Well, here, cast unit basis. Changes the base units associated with the input and return the results. And so this is basically, I almost never use this one. If you're using this one, you probably are making a mistake, is kind of my guidance there. But it is basically a way, it's kind of like the typecast function. I want you to interpret this number differently than the way it would by default. But convert unit is something that happens all the time. And so, well, not all the time, but what I've got meters per, let's turn this into something more normal, like meters squared. And then I say, I want this to be meters, meters squared, and create an indicator. And so now, this is that same value but notice in the help window that there's no unit associated with it. There is a unit associated with it, a meter squared on the input, but I am telling it, remove the units here and just turn it into a number that is equivalent to meters squared. I could also say, I want you to interpret that as feet squared. And so now this will be a number that represents feet squared. And there it goes. So 33 meters squared, 355 feet squared, but there's no unit associated with that. So that's one of the ways of, okay, if I write some part of my algorithm to use these physical units, but then I need to plug into somebody else's application that I'm not ready to change to be unit aware, I just need to hand them feet squared, then this is a way of like, I can now give you this number at the edge of my VI and then hand it to you and do it that way. Same if you're passing me in something that's feet squared. This works both directions. And so if I had a numeric here, numeric 2, that does not have a unit, and I say I want to interpret that now as feet squared, we see, well, it's going to use the SI unit of meters squared as the data type of that wire coming out of there, right? So, but it's telling me to interpret this number, so 355, and then it goes with this one. If I run that, that's about just under 33 meters per meter squared, right? So this can either take something with units and convert it to something without units, or something without units and convert it to something with units. It figures it out from how you wire it up. Does that make sense? Right? So that's where you would, like I said, whenever you're having to deal with things at the edges of your API that don't understand units, this is the function you would use. Okay, so in this case, in my customer case, they actually had a big formula node with some algebraic formulas and the formula node does not understand units. But it had, as I was changing things to add units to this, okay, this is feet, this is meters, this is seconds. Then I hit this formula node. What I actually did is I rewrote that formula node in primitives of add, subtract, multiply, and divide, and exponent, and things like that. And that way I could keep my units and make sure I did my math right, as opposed to converting it with the convert unit function and then call the formula node and then convert it back. I just let's get rid of the formula node. Let's get rid of the functions that don't support units. So that was how I handled that. Okay. Darren's feedback about units 3. So he does a lot of scripting. And if you do a lot of scripting, and because units are built into the data type, that makes these things a little bit different than your average front panel controller indicator. And so what his concern is that many VI-based tools, and he acknowledges he probably wrote some of them, forget to check for units. And so if you get type information and you basically just, I'm looking for double floats, then you will miss all the double floats that have a unit associated with them. And so I don't know how often this happens in the real world, that you use some scripting tool that needs to deal with something with units. I've never run into this, but I absolutely believe that this could be an issue for certain kinds of applications. Okay, so then, and Darren gave me a couple of other cases, which I've kind of already covered in my demo. And then when he sent me these, I said, well, let me pile on some of my own complaints about units, which I turned into a wish list. Actually, before I do that, there's one other thing. I don't think I actually put it in here, but I wrote a little demo about it. So if I want to call a sub VI, then the sub-VI has to match the units, which can be a problem. That limits the reusability of that sub-VI. I think it's this one. Yeah. So, say I want to have this sub-VI that what it does is take an input A and add it to an input B, and then produces a result. And, well, I could make one for meters. I could make another one for meters squared. I could make another one for velocity, meters per second. I can make, so that was annoying to Jeff. And so he invented this idea of the polymorphic unit, which is actually one of my least favorite parts about units, but I felt like for completeness, I should talk about it. And so one of the things you can type into a unit label is something like $1 and $2. And so then the unit computation will say, okay, if I'm multiplying 2 units together, then it's going to be $1 times $2 is my unit. And if I'm going to add, let's see, in this case, I'm adding A to itself. So $1 added to itself will yield a unit of $1. And then when I call it, and then, so I can run this as is. And it seems to just do regular math, right? But I can then call it, so this is that sub-VI over here. And so I can say meters and feet. Okay, here's one of the things I don't like about polymorphic units is I can create an indicator on this. And even though this is the x plus y, so even though that should be like meters plus feet, it puts $1 here. So I can just say, I want that to be meters. And similarly for, this is going to be feet squared, say. Okay, so then finally my wires are no longer broken. Right, but then I can run this and say, okay, 2 meters and 6 feet should give me, almost 4 meters and then almost 40 feet squared. Right, so the sub-VI there is just building in some unit math without knowing what the unit is going to be based on those SI, the base SI units that it knows are going to be in the data that's flowing down the wire, and then leave it up to the caller to figure out how to present that to the user. Okay, Greg.
Just saying, it's another place where adapt to source in the sub-VI would have made the create indicator work.
Adapt to source and adapt to source. I am so glad you are here, Greg. It's better even than having Darren here. And you can tell Darren nice things. Hey, look, no broken wire. Yep, create indicator. I notice it takes a second, but
That's your button.
no, I don't want to add history. Okay, yeah, thank you. That's awesome. Okay, so I don't know if I said it here in my wish list. Yeah, I don't. But poly VIs, I believe. Oh yeah, there's Darren. Hi, Darren. Thank you. Yeah. Did you hear the part where I said that having Greg R here is better than having Darren here?
I agree with you.
He told me about adapt to source and how it works with units. Like I had no idea. So anyway, that's my big learning for today. Okay, so I've already covered Darren's feedback about problems with units, which I 100% agree with. I told him yesterday, it's like, I will represent your opinions, and no, not opinions, but truth. I will represent your truth. Polymorphic units, there's a bug in polymorphic units that has to do with degrees, Celsius and degrees Fahrenheit, but I can't remember exactly what it is, but it has to do with, those are the only two units where the zero crossing is not the same depending on your, because it's minus 273.15. But I can't remember exactly. I tried to reproduce what I thought the bug was, but I couldn't reproduce it. But do you remember?
We distinguish between degrees Celsius and Celsius degree.
Yeah, I was going to mention that next.
Yeah, and that's what it has to do with.
Okay. Yeah, that's another thing I didn't point out. But, oh yeah, I actually did want to show this. So if you right-click on the unit label, there's a thing called build unit string that brings up this dialog, which starts to help you construct the unit. And so it's like, I want to represent a luminous flux somehow. And so it's going to be lumens. And I want then to add another unit that is candelas, but I want to do 1 over that, and so on. And I want that to be teracandelas. Right? So this actually helps you, because it's kind of hard to remember, some of these things. And this is where the derived units, like I believe a becquerel is derived from Curies and things like that. So you can start to figure out, various things. But one of the things that Greg just mentioned is there's a difference between Celsius degrees and degrees Celsius. So a Celsius degree, 1 Celsius degree is the same as 1 degree Kelvin, and it's the same as 5/9 of or 9/5 of a Fahrenheit degree. But then a Celsius degree, and may have these backwards, but one is the absolute, like 0 degrees Celsius is 32 degrees Fahrenheit, but a 0 degree Celsius is a 0 Celsius degree is a 0 Fahrenheit degree, right? Because it's relative versus absolute, right? So the absolute units are based at minus 273.15 degrees Celsius is 0 degrees Kelvin, and so that's one of the things that you'll notice. And so the way it's represented is degrees C versus C degree. So I think Celsius degree is the relative unit, and degrees Celsius is the absolute unit. And then that's where polymorphic VIs, because it doesn't know the zero crossing and the math that it's doing, can sometimes come up with the wrong answer, but I cannot remember how to reproduce that bug. But
the easiest way is if you subtract 2 absolute temperatures, you get a relative temperature. But the polymorphic units don't know that they're going to be dealing with temperature, so if you subtract between 2 united values, you just get that unit back. So it would give you an absolute temperature, but it's really not, it's a relative temperature.
Yeah, thank you.
That's what it gets wrong.
That's correct. Yep. So this is one of the few boundaries that we have to worry about. So, but thanks for remembering that detail. Okay. My wish list. So at some point during when I owned units, I wrote down, here's the things we ought to do about units, talked to Jeff K about it. We decided not to do it because it's just not as important to work on this part of LabVIEW as it was to work on other parts of LabVIEW. It was the right decision to make, it still is, I think. So allow for user-defined units. So if somebody wants to have sheep, they can have 5 sheep, and that can be a unit, and that's fine, right? We don't need to, again, don't judge. And so that was, or even if they are SI derived, it would be nice to have, some way of defining your own unit. Well, we didn't have that. It's basically whatever was hard-coded into this big table that gets compiled into the block diagram. Non-linear units, such as decibels. See, decibels are not actually they're unitless, but they're nonlinear, and so it would have been cool, to have some way of describing nonlinear units or nonlinear representation somehow. And then the biggest thing was there was no runtime API for dealing with units, right? Everything's compiled in, right? So there's no way, like, I have something, I want you to run some unit math on this and give me the result, and there's nothing there. Even though LabVIEW has that engine essentially built in internally, that it would have been nice to build an API on top of that. And so that would be my wish list if NI ever decides to do units, invest in units. This is what they should work in. This, I hope, is not one of the things that's on the roadmap for LabVIEW at this point. I believe NXG was going to kill off units, but instead we killed off NXG, which was the correct decision. Just like I told you in 2005, Greg. I wrote a couple of blog posts a couple of years ago about units. You can go read those for more information. But let me open it up for a couple of minutes of questions and see what questions people have. That works too.
Things like taking a cluster and then saving that as an XML, convert to XML and saving that. Does units work with that well?
I seriously doubt it. If I convert my data, I can't imagine that function would work with units. And so that's where you would use convert units to
are there any file saving type things that actually do work with them properly?
Yeah, basically I think all of these conversions to strings, you're going to have to figure out, you're going to have to remove the units with convert units, and then you can convert it to a string.
Gotcha.
There's an off chance that it might just use the base SI units, and so if you have on your front panel feet, it may write out something with units. No guarantees though, but that's maybe by default what would happen.
What happens when test stand interacts with these VIs? Does it pull in units?
So if test stand is interacting with a LabVIEW VI, and the LabVIEw VI understands units, everything's probably fine. But as it gets data, test stand has no concept of units. So it's going to get the SI base units if it's just going to get the value. So it's not going to be unit aware in any way. It's another place to use convert units. Mark, you had a question. Oh, back here. Go ahead.
Hi, I've got a comment. You said at the beginning of the presentation about not being able to set SI units as a standard representation for numeric. Do you remember?
Not being able to...
You said it would be really nice if you could set the SI representation.
Oh, the SI notation for display format.
On a display format.
Yes.
Yeah. I work a lot with binary and hex numbers, and I hate having to set the show display format and set the format every time. So I actually made a palette of numeric controls with all of the representations needed, and then I can just use quick drop to drop the front panel controls and the constants.
Yep, that's a good idea. We'll give it to Mark and then Aaron. And then we'll about done.
Does unit support degrees or radians? Do you know?
Yeah, I believe so. Angular.
There's angle, right? Second one from the top.
Angle.
So just as a follow-on to you having created a number of defaults, there is, and I'm forgetting the name of it, I learned about it a month or so ago, there is a VIPM package where someone gives you the ability to save your own defaults that you can readily for the numeric say, hey, I always want to use this one. And so someone did create a plugin for that. I was one of the people that raised my hands because I do regularly use units in certain portion of the code, especially UIs where users are having to enter time information. Because if I want to ask them how many minutes do you want, how many hours do you want to run this test for, an endurance test, I can just use those units right there. It all converts to seconds under the hood for my timing engine. I don't have to worry about, am I dividing by 3,600? Am I dividing by 86,400? It just does it for me and reduces the risks of me mistyping something.
Yeah, that's kind of what I had too with my application that was using 80 megahertz ticks. I actually just converted the data type that was being shared among multiple applications to seconds. And then right before you talk to the counter timer board, deal with, well, in DAC and MEX, you can actually talk about seconds with that. All right, we're done. We're out of time. Thank you very much. I hope this was helpful.